Okay, so I'm going to talk in this video a little bit about an overview of the reactions of alkenes. And to start off, we're going to talk about a couple of reactions of alkenes, addition reactions of alkenes that we've seen before. We have, for example, the reaction of an alkene with HBr, which adds in a Markovnikov fashion to give the Markovnikov addition product. And the other reaction you've seen already is the Markovnikov addition of water with an acid catalyst to give, as you've also seen before, the Markovnikov alcohol. Okay. Now these are just two examples of reactions addition reactions you can do with alkenes, and there are some others. So let's just have a look at another slide here, and let's say we have this alkene. All right. One thing we can add to an alkene is some sort of halogen. I'm just going to say X2, and that X can be usually chlorine or bromine. All right, and we can't talk about Markovnikov addition here because it's the same atom that's added each side of the double bond. But what we end up with is addition across that double bond, but the important thing about this is if one of the X atoms, hang on a minute, let me delete that. What you have here is a situation where you get this thing called anti-addition, where the two X's add on opposite sides of the double bond, as you would expect, but they add in opposite ways to each other, and I'll have a separate video about exactly why that is the case. So if I put one on a wedge here on one carbon, sorry, that should be an X. Bloody hell. Maybe I'm doing this too late. Anyway, so if this is one of our X's here, then the other one is added opposite to that. So if this one is pointing up, then that means that this one must be pointing down. So I'll show that by a dash. That means anti-addition, okay, meaning one up and one down. Or it could be one down, or one up and one down here. Let's see, one of the other things that you can do is a very similar reaction where you take your X2, again, chlorine or bromine, and you add it to the alkene in the presence of water, and you get something called a halohydrin. You get anti-addition once again, but in this case you get addition of one X, one equivalent of X, and one equivalent of OH. So let's not worry so much about stereochemistry here. We get an X here, and we get an OH here. So this actually is Markovnikov addition. Markovnikov, that's a mess. Markovnikov. Alright, so what we have here are two reactions that follow broadly similar patterns. This involves an intermediate bromonium ion, as does this. We'll also see, let's see, we'll also see a reaction called oxymercuration demercuration, which is another way to make a Markovnikov alcohol. And that involves a two-step process. First step of which is mercuric acetate, that should be a 2. And then the second step is reduction to remove the mercury. And what we get is, it's essentially another way to make a Markovnikov alcohol. The other way to make the Markovnikov alcohol is what we saw over here. The main difference between this method and this one is that with this method you don't need the strong acid to make it H3O+, and so this method is considerably more mild if you have other issues to worry about. And let's see what else. There's also a way to make a anti-Markovnikov alcohol, which we haven't seen before, and this is by something called hydroboration oxidation, where we'll take BH3 in a particular solvent like THF, and again I'll probably post a separate video about this, and that will add across a double bond, and then we will oxidize that boron, usually in a step where the mechanism isn't detailed, and that will be the case here, where we actually get to put the OH on the anti-Markovnikov carbon, so the carbon that's least substituted. Usually the OH goes on the carbon that's most substituted. And then one of the other things that we'll talk about is addition of an epoxidizing agent, MCPBA for example, which is metachloroperoxybenzoic acid, to take that double bond and open it up and put a peroxide, or just an oxygen here, giving you a functional group of an epoxide, which you'll see later on is actually very unstable and very viable to being broken open. Anyway, so these constitute several different reactions that alkenes undergo. There are a couple of others, but these are the main ones, and the ones that we will focus most of our time on.